Okay, let's continue. We talk about the binary to hex conversion. How do you convert from binary to hex conversion or hexadecimal? So if you have a binary number like what we have here, okay, we are going to separate it, or we octet, how may I call it, put it in groups of 4. If you put it in groups of 4, when we start from the other side, then we shall have a 0, which is this up to this. Those are the 4. Then we have this up to that to make a 4. And now lastly we have 1 1, and 1 1 unfortunately cannot give us a group of 4. So what do we do here? We just add zeros. So when you add a 0 and you also add another 0, and you have 1 1 to give you 4. So that is why basically you're seeing around here these zeros to make 4. So we know that this one gives us a 3 in base 10. So, and remember, a 3 in base 10 remains a 3 in hexadecimal, which is around here. So a 3 is this, and it remains a 3 here. So still this one 1010 gives us a 10, which is this. Okay, and here in decimal it is 10, but in binary in hex it is A right here. So we have an A around, and then this one gives us 6, which is around here, and remember it remains the same like that. So 6, and therefore we have 3A 6 base what? Base 16. So that is how we can convert from binary to hexadecimal. All right, let's go on. We see binary coded decimal. So they are saying that each digit of a decimal number represented by its binary equivalent. So in BCD, actually this is binary coded decimal. We talked about them, and we said these ones, they obey what we call positional principle. So if you have an 8, okay, we said write these numbers. You have 8, you have 4, you have what we talked about, you have 2, and lastly 1. We said that these are powers of 2 less than 10. So in 8, can I get the 8, what we talked about? Then we shall say yes, and then I've remained with the 0. Automatically these others are going to be zeros, and that is how you come up with this value. If you have a 7, still go through the same process. So in 7 you can't get an 8, and automatically this is going to be a 0. And then in 7 I can get a 4, that is going to be a 1. and remember that I've got a 4, so I've remained with a 3. So 3, in 3 can I get a 2? Yes. And then they have remained with a 2. Sorry, I've remained with a 1. Okay, I remained with a 1 because I've taken a 2. So in 1 can I get 1? Yes. So simply 7 is an addition of these numbers here only. So you have to flag them on, and then you flag 8 off. Now 4 is already appearing here, so others are zeros. That's how you get the BCD conversion. Okay, so you are saying only 4-bit binary numbers from that through this are used, and then the B. Now let us compare the BCD and the binary. In BCD we have seen that we have this. So if you have 137, this is going to be equivalent to this. Remember, you're going to get this and that independently. Okay. In 1, remember a 1 is going to give us 0, 0. A 1 is going to give us 0. Anyway, when you get this in binary conversion, you convert 137 to binary, you're going to get something like this. Okay, but when you get the same number 137 and you convert it to BCD, you're going to get this, and therefore they are not the same. So this is actually a 1 here, and this is a 3, and this is a 7. But this one, you convert it to decimal. We know how to convert. So let's count these numbers. We have here 4 plus a 4 plus a 4, and that one gives us 12 bits. And here we have 1, 2, 3, 4, 5, 6, 7, 8. So here we only need 8 what? 8 digits. So alphanumeric whatever characters, we know these ones, 10 decimal digits, and we have 26 letters. So alphanumeric means getting alphabet plus the numerical values. Then we have characters like an addition, equal signs, and all others. So a complete list of ASCII. This is what? American Standard Coded. Is it information interchange? Something like that. All right. So we shall look at complements in the next video.